Hello, everyone. We just want to thank you for joining us today. We have Hilary talking to us about her DFI project that she did with her students and using Python. So without further ado, we'll let you take it. Thanks.
Okay, awesome. Thanks, Ashley, and thank you guys for joining. I know this is not the best time of the semester to have optional things added to your schedule. Let me crap. I hate the way that sorry, it's blocking there we go. Oh, is it showing? Hold on, I'm sorry, guys.
No, you're totally fine.
Okay. Do you see the full size now?
Yes.
Okay. Sorry about that, guys. He would think I would be better with technology if I'm going to be talking about Python, but not quite. Yeah, so I'm going to be talking about a project that I incorporated into one of my classes last spring as part of the project that I had proposed for the DFI fellowship that I did. It's been, was that summer 2022, I think was whenever I started that. And so hopefully you guys aren't hoping to learn a ton about how to use Python because that's not what I'm going to focus on. I really just want to talk about why, kind of my motivation behind wanting to incorporate this project into my class, how it went, and kind of what my plans moving forward are. So before getting into my class, a little bit of a story time, if you'll indulge me. So back in 2015, when I was a first year grad student at Purdue, I joined a research group that did chemistry that was not any sort of chemistry that I would have ever thought of. It didn't occur to me that chemistry could be more than just mixing chemicals together and doing reactions. So the group that I ended up joining actually had a pretty significant computer programming component to it. So we were building instruments, and all of them are from scratch. And so in order to actually have the instruments do the thing that we needed them to do, we had to write our own software for analyzing the images that we were looking at, for running the instrument. And in my undergraduate career, I hadn't taken any programming courses. It wasn't part of our requirements for graduation. It wasn't even really a thing that was talked about. And so I kind of felt like I had gotten the short end of the stick of not getting that experience going into grad school. And I never really felt like I was able to catch up in my research group. It was just an aspect that I wasn't capable of teaching myself, at least at that time. And so that kind of frustration has always kind of lingered with me. And so coming here, I've had this interest in hopefully exposing our students to that a little bit more. So it really kind of stemmed from my own frustration from my undergraduate career that I'm hoping to change for our students. So for a little more context, currently there's only 28 institutions in the US that offer a computational chemistry degree, none of which are small liberal arts colleges. They're all larger R1 institutions. But despite that, it's a very prevalent field within chemistry. So super common with data processing, any sort of data that you're trying to analyze. It's used in chemical and structural modeling. It can be used to, if you're trying to determine the best conditions for a reaction, or you're trying to determine what chemicals or substances are going to react to form what sort of products, you can do sort of AI predictive analysis using programming. So it is really prevalent in chemistry, but for some reason isn't quite talked about in the undergraduate curriculum. And I did try and do a search. As far as I could tell, none of the colleges kind of associated with Franklin offer any or have any required, even just a single programming course in their curriculum, and especially not chemistry specific programming courses. So it's really an aspect that's kind of not present in undergraduate chemistry curriculum, but is very prevalent in the field post-graduation. So as part of my work with the DFI fellowship, I was able to connect with another faculty member, Charles Weiss, who previously taught at Wabash for a few years as a visiting professor, and now I think he's at Augustana as a full-time professor. But he actually wrote a textbook on using Python specifically for his chemistry courses, and even created a computing for chemists course while he was at Wabash because of recognizing kind of this hole in the chemistry curriculum. And so I had come across his name from this article of kind of just an opinion piece as to why he thought that this was important. He mentions in the article having a conversation with a colleague who had interviewed for a job. And in that interview had been asked about their experience with programming. And the interview themselves said that it's a skill that unfortunately most chemists joining their company don't have. But it is a skill that employers are looking for. So my goal was to try and address this lack of programming within the chemistry major. So my overall goal for the project wasn't necessarily to teach them how to write their own program from scratch. That feels like a kind of heavy lift for students who have no programming experience. So really just as a first iteration, my goal was to just expose them to programming, get them comfortable with just the very basics so that hopefully moving forward, we could build upon that or kind of grow those aspects. So for the specific class that I taught, instrumental analysis, it's a 400 level upper level elective class that we offer. And so in the spring, typically when we teach that class, I'll have students use Excel for all of their post-lab analysis. And so any sort of the numbers that they're acquiring in their labs to process them to do graphs, that kind of stuff, they're using Excel. So they're very familiar with Excel. And so all I did was replace Excel with Python. So it's programming in that they're having to write code, but they're not, writing for loops or iterative type of code. It's really kind of just using it as a fancy calculator, is what I described it to them as. Again, in the hopes that once they've had some exposure, if I can build on this, we could get to some more advanced coding. And I was able to use what's called Google Colab, which I'll talk about here next, for the programming component. So they weren't required to download any sort of software or program onto their computers, and there was no cost associated with it because it's a free available resource through if you have a Google account. And so that's what I want to show you guys next. So I'm gonna, if I can, is it okay? Yeah, it's showing. So this is what Google Colab looks like. So it's essentially an online software that has Python built into it. And so what I created through my work with the DFI fellowship was kind of a very pared down resource for my students of just the stuff that they were going to need with my class. So I cut out a lot of the higher level, more advanced stuff that they wouldn't need to use. And essentially kind of like a very short textbook for them to know how to, sorry, I just had a student look at my window. I was like, no, go away. But how to do basic, mathematical functions, if they're trying to round values or calculate the absolute value of something. Let me see if I can, so you can see a bit better. Okay. But then just doing basic calculations, like if they're trying to add two values together or divide, or as you get to some more advanced things like doing powers or orders of operations, things like that. And then, talking about how they create a variable. So if they want to set up a calculation that they're going to do with multiple sets of values, they could define variables and then just change the values for the variables rather than having to do all of it from scratch. We do a lot of plotting in that class where they're having to make calibration curves. And so there's a section that walks them through step by step of how to create a calibration curve, how to do linear regression analysis, how to label axes, and change the color of their data points if that's something that they want to do. So this was really designed to just be the bare minimum of the functions and the abilities that they would need using Python. And then what I had them do was create their own notebooks. So this is one of my students from the class. And so they essentially use this as an electronic lab notebook throughout the semester, where for each lab, they would do their post-lab analysis. And so I could, just by them sharing the link with me, access their materials, look at what they had done, look at their code, and then leave comments to them directly on the work that they had done. So if they had, some error with their code, if they had done something incorrectly, I could just let them know directly on the work that they had done. And so I even, for one of the labs, they had to do a full lab report. And so I just had them do that in Google Colab. So I really liked the fact that there's coding, but then it's easy to add text as well to describe what they're doing. So for their full lab report, they had separate sections where, they give an introduction, they talk about their experimental procedure, all that stuff. And then in the results and discussion, have all their data and their data analysis and that kind of thing. So it was really just like kind of a one location hub for them to have everything that they needed for each lab, and that they didn't have to upload things. They just had to edit it on their end. And because they had shared a link with me, I was able to access it. And again, this made it easier because they didn't have to download some separate software. I think the program for using Python is notorious for being a very large program, using a ton of space. So I was able to circumvent that issue by just being able to use Google Colab. And so because the whole kind of point of this was to expose them to programming, I had them complete a pre and post survey for the class on their feelings towards programming. So I think one of the struggles is that students are just intimidated by programming. It's something that they haven't done before, and they think it's something that they can't do. And so they tend to have negative feelings towards just the idea of programming. And so I wanted to see if implementing this project changed their feelings. So I did this pre-survey and then had them complete the survey again at the end of the semester, where they were doing word association essentially. And so they had to, pick which value corresponded to how they felt towards programming. And so a bunch of different word associations. Whenever I show the data on the next slide, keep in mind that it's not like all positive words on the left, negative words on the right. So that they couldn't just kind of cheat the system. They had to actually like read through the words. So the differences that I'm going to show don't necessarily all correspond to positive or negative. I think it'll make more sense on the next slide. Anywho, so looking at the change in the score for their pre and post survey, I've tried to, the numbers that are boxed in green are the ones that resulted in a positive change. So the score shifted to a more positive feeling. The red boxes are the ones that were a more negative feeling. And then the ones without boxes, there was just no difference in the scores that they reported. I think what'll make more sense. So obviously key takeaway, I feel like bottom line, way more positive changes than negative changes, which I feel like was good. But to help demonstrate this, again, green boxes are the positive changes, red boxes are the negative. So I The ones that had the greatest change in terms of positive were easy versus hard. So most of them did feel like they felt that programming became easier as a result of this project. The confusing versus clear was also a significant positive change. Comprehensible versus incomprehensible. And then the one that I was happy with was comfortable versus uncomfortable. Saw quite a significant positive increase from before and after. Because again, I think they have this kind of discomfort with just thinking that programming is very intimidating. And obviously a few that resulted in a negative change. So things like exciting versus boring. I would like to do a better job of getting them excited about programming and showing them all of the benefits that they can get from it. Satisfying versus frustrating. I hope that just with more time that improves, but programming can be really frustrating as you're trying to troubleshoot code. But so overall, I was really happy with the results, and that there had been some positive improvements in implementing this program, this project. So my future goals, future plans for this project. In the short term, I'm hoping to, so this was again a 400 level class. I'm hoping to incorporate some programming aspects into analytical chemistry, which is next fall, that I can hopefully get them exposed to programming a little sooner, so that when they take instrumental analysis in the spring, I can have them do some more advanced skills. That's my goal anyway. Long-term goals, I would love to offer a class that was just focused on either Python or programming, just in general, if we want to use a different language, but for chemists or even just for science majors, to show them how this programming tool can be used in their respective fields. And then I just want to do a quick shout out to Sarah Summers and Andrew Rosner, who were a huge help with the DFI fellowship. Again, that was how I was able to connect with this faculty member, Augustana, who was just a wonderful resource and wealth of information. And then I was able to purchase a couple of textbooks that helped me teach myself, because I had zero experience with Python prior to this project. So I was able to get a couple of textbooks and then just general help, some back and forth conversations with some of the other DFI fellows of what they suggested. So wouldn't have been possible without them. And that's all I got. So if you guys have any questions, I'm happy to answer those. Again, I know that wasn't a deep dive into Python itself, so hopefully that's not what you were expecting. I feel like that wouldn't have been enjoyable to listen to anyway, and I don't know how much ground I would have covered in 20 minutes. So, but yeah, if you have questions, let me know.
Do you think, Hilary, that your students are, or do you have any sense that they're going to be more likely to seek out like internships, or have you been able to identify internships where they might be able to do some of this work, as opposed to now that they're more prepared to, I guess?
I don't know. I don't know if there's been enough time from when I taught this project for there to see a change. I do know this is going to sound like I'm shitting on one of my students, and I promise that's not what I'm doing, but I had a student that did an internship this summer, and they were complaining that there was like this specific thing that they had to do in their internship that like we hadn't taught them, and they're like, oh, but it was really easy, I was able to figure it out. And my frustration was like, you could figure it out because of all the stuff that we've taught.
That's the point.
Like my job is not to teach you every single thing that you need to know, is to teach you how to teach yourself. So in that regard, I think whether they realize it or not, that just having gone through the fighting through figuring out how to teach yourselves how to, program, like that's literally what I did, and had a day where I was about ready to rip my hair out because I couldn't figure something out that they needed to be able to do. And then I figured it out, and it was like, oh my God, I'm amazing. Like, I'm so smart. So I think they got some of that. It was just a bit of a struggle throughout. So yeah, I don't know. I haven't heard specifically. I know that some students expressed a greater interest in wanting to pursue some of the data science options. Like I had a student that was planning to do a data science minor. So stuff like that. But I don't know if there's been enough time to see like a trickle down effect of if it's increased their interest in programming. It's also the first time, so I'm hopeful that like the more that I do it, iron out some of the kinks, and again, my goal is to get them exposed sooner so that we can do some of the cooler, more impressive things that can be used with programming.
You happen to hear, I know you took the survey that was like their comfortability or knowledge of it, but did any students like mention or bring up that they had to do this or maybe had an internship? Like, did they have any connection prior to this being brought up that, oh, I need to figure out how to do this?
I don't think so. My sense was that they didn't really understand why we were doing this. And I tried to, like, I know why it's valuable, but convincing them of that is a whole other battle, and so I think because what we do here is very structured, right? It's designed to be an ideal situation, and so all of the data processing that they're doing can be done in Excel. In the future, even if the bare minimum all they're doing is data analysis, if they have huge sets of data, like there's a limit to how much Excel can handle. So even just in that regard, there's a point where Excel doesn't work for even the most basic things, right? And I think that they don't have a sense for what a huge data set looks like. That's another thing that I would like to, in future iterations, do some like big data type projects to show them, here's why we can't always use Excel, right? Is because we have this huge data set, Excel breaks, right? It can't handle that many numbers. So then this is why we need to know alternative ways for processing data. So I think that's one area that I need to do a better job of getting student buy-in and showing them that it is beneficial. But I think just because, the internships that they're having, they're not necessarily getting exposed to it. So I think they're convinced that like, why do I need to know this?
I wonder if Andrew Rosner might be able to use the Digital Fluency Advisory Council to help you find somebody who would be a good speaker or something who would, students hear those things sometimes better from other people than they do from us. But that might be a good use of that group to find some connections of folks who can either, share or show a really big data set and how they dealt with it, or just give them an example of how they're doing that in their own work.
No, I think that's a really good idea. And I think one of the struggles that I had, and the reason that I would like to create a whole course on this, is the class that I incorporated this in is not a programming class. Like that's not the point of the course. And so it was this hard balance of, I want to do this, but I can't devote lecture time to teaching them programming, to, that sort of thing. It was really we're going to add this into our lab component, but it was like kind of a secondary objective of the course. And so I would like to, I don't know the fine line between it becoming a course that is not supposed to be, where it's all programming, versus the actual like content that I'm supposed to be teaching. But I think like some sort of guest lecture of somebody that is actually using programming in the chemistry field, to show them like, here are some of the things that we're doing, like I tell them, here's all the stuff that I did in grad school and why I wish I had programming. And they're like, yeah, okay, Dr. Florian, we don't really care, but if they hear it from somebody that, if I could get somebody from Eli Lilly or somebody that works somewhere that they like, aspire to work, I would hope that would have more of an impact, but.
Yeah, I had just asked because that's not something I would have expected.
But I think that's the problem, right? Like that I was the same way. That's why if I had known, like I remember when I was in an undergrad, as I was taking like calculus classes, I had so many teachers that would say, oh, well, if you know linear algebra, this is so much easier to do. And after hearing that like 4 or 5 times, I'm like, why do I not take linear algebra then? Like, why do you keep talking about this, but I don't take it? So I took linear algebra just for the heck of it. if I had heard like, oh, computer programming is actually really beneficial even within chemistry, then I would have considered taking a class, but it wasn't even talked about, wasn't even suggested of like a potential like elective course or anything, and definitely wasn't required. And then I get to grad school and I'm like shell shocked of what do you mean I'm supposed to know how to program? I'm a chemistry major. Like I took chemistry, I didn't take programming, you know. So that in that regard too, I'm hoping that just more exposure, and again, trickle down effect of after a few years of doing this, if I can incorporate it earlier into our curriculum, that'll become just kind of second nature within our, you know, major, but definitely not there yet. So
Did anybody else have any additional questions for Hilary? No. Well, I just want to thank you again for taking time and sharing this with us. It was definitely enlightening. So I am interested to hear, you know, in the future of what changes you're able to make or how you're able to incorporate it. But if anybody has questions, feel free to reach out to myself or Hilary. And just thanks so much and hope you enjoy.
thanks for coming, guys. I appreciate it.
Thanks. Bye.
Am I good to go, Ashley?